Hello once again, my dear 9th standard students. So it is the third chapter. Okay, this is the third chapter. Too much hot. It's very hot and humid here in Kerala. Okay, so this is the third chapter we are going to study, and it is from the most easiest part of science. Okay, this is from physics. Okay, welcome to physics, my dear kids. Welcome to physics. Okay, don't be get tense. Okay, don't be get afraid and all. Welcome to 9th standard physics. And the first chapter is about motion. Understand? Motion. Before jumping into this topic, we will discuss some basic things regarding physics. Okay. Actually, for almost 60-70% of the student, physics is like what? It's like a twister. They are very difficult to understanding this physics. Okay, so let us see what is the main problem regarding this physics. Actually, this is not a problem. It's a bit more, what you say, concept you need. If you want to study physics very well, your basic concept must be very strong. Then it will be very easy for you to study this physics. But if your concepts are not that much tight, its basic concept regarding this physics, it is very base. What all things are happening around us, just look and watch. It's a common sense you must feel to understand this physics. It's only common sense. For example, if you are running through a straight line, understand, in the ground, and suddenly you are turning your direction, what will happen? If you didn't slow down, you will fall down. Right or not? And 10 meters away from here, there is a wall. You are directly running through the wall. You cannot run through the wall. You are running towards the wall. And if you don't stop before the wall, what will happen? You will hit the wall and we will be getting injured. Understand? So all those common phenomena which is happening around our world, we can relate it with physics. Okay, what all physical things we are seeing. Actually, it is a natural phenomenon. Understand? Wind blows, the leaves are moving here and there. Why? Because the wind is exerting some amount of force so that the movie is moving. That is also one type of motion. Understand? Rain falls down. Why? Why is it not going upside? Why is it not going sideways or in circle? Why? Because of this gravitational pull from the earth. That is also part of science, isn't it? So in olden times, what really happened, like 500-600 years before, there's a lots of experts in these types of subjects was there. For example, like Archimedes and all. Archimedes, Galileo, Pythagoras, lots of different types of very well-educated people regarding this science, they were there. But what they are making, they are simply making theorems. Understand? Practical proofs they are not giving. Simply they will tell. During that time they believed that Earth was fixed in a particular point and these planets, Sun and all others, they are rotating around the Earth. For thousands of years, human beings believed that. It was written in Bible also. Actually, in Bible it was written that the earth is flat. Not only in Bible, the epics of these Greek people, Iliad and Odyssey, that also it is written that earth was not round, flat. But the Magellan, a man who proved that earth is a sphere, he rotated the entire earth. From one place he started his journey, he reached back in the same position. So he confirmed that earth is round and sun is the center of the solar system and the 9 planets. Before there was 9 planets, now it is only 8 planets. They are rotating around the sun. And not only that, they are rotating around the sun. At the same time, it is rotating around its own axis. Okay, like this it is going. It is rotating around its axis. At the same time, it is revolving around the sun. So these are basic concerns. I think first scientist who started to question all these things, it was Galileo. Understand? A famous, he was an optician, at the same time a great mathematician also. So what he did, he just referred these theorems made by these scholars, and what he did, he wanted to prove it. If it is correctly written in these papers, you must prove it. So Galileo started to conduct experiments. Understand? Lots of experiments are there conducted by Galileo, and he was very famous for one thing. What is it? Yes, telescope. Understand? He was very famous for his telescope. Actually, Galileo is not the man who invented the telescope. Understand? He made a very high advanced telescope so that he can see the sky with that. Actually, Lippershey is the man who invented this telescope. So Galileo, what he did, he tried to do a lots of experiments. Understand? He started observing the sky. And after observing a lots of things, lots of days, then he came to a conclusion. So there is a lots of millions and millions of stars are there. Not only the Earth and the other planets, lots of stars are there, even another galaxies are there. Our galaxy's name is Milky Way, is it? Another galaxies are there. That means the sky is very, very, very huge. Understand? We are just a small piece in that, just like a tiny dot. If you consider the entire galaxy, entire sky, our Earth and everything will be just like this one small dot, very small dot. So all these things were the discoveries of physics, mostly physics. So when this physics discoveries was very, very high, not only discoveries, this invention also was there. Okay, modern and ancient. What happened? The life of the people changed. So the people, before they believed that the earth is flat, so that if we move straight in one direction, there will be a dead end and you will fall down to death. And they are telling that that is hell. Understood? That is hell. That's a simple belief. You are believing earth is round because you are studying in your textbook. Maybe from childhood onwards, you have been told that earth is flat. Your parents told the earth is flat. Your teachers already told earth is flat. Your neighbors, your friends, even me, I am telling that the earth is flat. You will also believe that the earth is flat. Anyway, you are not going for any, conducting any experiment regarding that. Can you take one ship and travel like Magellan? Maybe, who knows. But yours, whatever things we have in our mind, it is based on assumptions, isn't it? We are just assuming. We are reading the book and we are understanding that, oh, the earth is round. So all this concept comes from this physics. Actually, it is a particular subject deals with a lots of concepts. In real, we can say that physics is the study of matter and energy. Matter and energy, and here we are studying about this matter form. Matter, I think matter was its first chapter. Yes, matter says. So, actually the main definition for physics in higher classes, it is a science that deals with the properties and interactions of matter and energy. But at the same time, for 9th standard, that much deep physics is not there. It's only base, very, very, very basic concepts of physics. So definition will be like that. It is a science which deals with the natural phenomenon what is happening around us. Daily happening. Not only natural phenomena, man-made or artificial phenomena also is there. Like our artificial satellites are there. Our GSLV and all, that's not a spacecraft. Our INSAT satellites which is creating, or Chandrayaan and all, they are artificial phenomena. For example, flying of a plane. 500 years before, anybody imagined that human beings will be able to fly as fast as birds or even more fast than the birds? Nobody imagined that. Okay, till 1905, the brothers who made the plane. So everybody imagined that a small phone will contain every details in a computer, and it has more speed than the computer. Have you heard that the first computer which was made by Charles Babbage, it was almost big, like a big room. That much big computer. And now the mobile phones which you are carrying in your bag or your pocket, it has 100 times more capacity than that computer. Anybody imagine those things? So all those things comes from what? It comes from the basic concepts of physics. So it's a natural phenomenon. Try to understand it. Okay. Each and every class of physics, I will try to take more time and explain all those things very simply. Otherwise, once you didn't understand this basic concept, it will be very difficult for you in your life. Very difficult. If you are planning to choose science as your main and you are going for the technology field, engineering field, so here is your starting. Understand, wherever you go, these things you will see: motion, distance, displacement, scalar, vector, magnitude, direction, SI units. Some of the things is not in the introduction classes of our books, but if you want to study physics, you must go through all these things. Okay, these are the basic things. I will post the same video for 8th standard also, because they also want to know about these basic concepts. So I am taking more time to explain all those things. Okay, we will just try to go with these basic things in today's class. And once you get that basics concepts, automatically you can understand physics. But now when you are reading those textbooks and all, it's very difficult for you. Oh my God, what is this? It will be very difficult. But that concept, when you got that concept, then simply you can read the book and everything is fine. So let us start. Here, the first chapter from the science is regarding motion. Understand, this is motion we are going to study in physics. Understood? One more motion is there. That's the biology part. That's not the part we are going to study. This is motion in physics. Motion in biology is another thing. But this is the motion which is happening in physics. So you have studied from the day you started studying science. From the day you started studying science, you came to this word called as motion many times. Give me a simple definition for motion. A simple definition. Any simple definition for motion? Anybody? How can you say? No. Okay, motion means, actually I didn't written that, isn't it? Okay, motion is nothing. The change in position of a body with time. Change in, I will write it here. Motion, change in position. Change in position of a body. So this is the simple definition for a motion. You already studied that. Is it difficult? Change in position of a body with time. No, I think it's not difficult. It's very easy definition. So before starting again with this motion, this is the old definition you studied, but now you must understand a bit more things about this motion. Motion can be described in terms of distance moved or the displacement. So today we will discuss about distance, displacement, scalar quantity, vector quantity, magnitude, direction, and international system or SI units, which is we using in not only in physics, in chemistry, biology, but all mathematics. These international units is same. So let us start with. So what you want to start? This one, or this one? Or I want to stop it. Anyway, it is not possible. I know that physics is not that much interesting part. It's not that much interesting part like biology and all. New things, new words, colorful textbooks and all are there. Chemistry means new chemical equation, balancing and all. That particular type of experience is different. When it comes to physics, it is like old classical physics. This is old classical physics, very old. Done by our great physicists like Newton, Galileo and all. Very old means classical physics. So try to concentrate more during these physics classes. So today first I will tell about this international system or SI unit. So what is the importance of this SI unit? Why we are using this SI unit? For example, somebody come to you and you will ask, how many kilometers from here to market? Sorry, I already tell kilometers. How much distance is there from here to market? What will you say? You will say, sir, 2 kilometers. Okay, fine. But in some places, they are not using kilometers, they are using miles. So 2 kilometers becomes 1.6 miles. If I am coming from a country where I am using miles, M-I-L-E-S, miles, and you are from India, mostly we are using kilometer here. So I came and asked to you, actually 2 kilometers is the distance from your home to market. I am asking you, where is the market? You will tell, just go 2 kilometers straight, you will reach the market. I heard 2, oh, fine. In my mind, 2 means what? I am using miles, not kilometers. So I will walk 2 miles and I will check for the market. Where is the market? Market is not there. As you told, just go 2 kilometers, there is market. But I am using miles. I didn't count it in kilometers, I counted in miles, so that I covered that distance. And I am checking for the market, there is no market. Then I am sitting there and I am blaming you. Oh, you just cheated me. Isn't it? He or she told lies. So that confusion will come. Understand? That confusion will come. Because in different parts of the world, we are using different types of measurement. For example, these are the basic measurements we are using. For example, length. What we are using? Not kilometers. We are using meter. Understand? Meters. Length, standard units is meter, and this is an international system. It's an international system. Entire world we are using these things. Next, when it comes to time, we are using seconds. S. When it comes to temperature, yes, temperature, what? No. We are using Kelvin, K. Understand? Kelvin. Okay, not degrees Celsius. Next, mass. We are using which one? Of course, kg. When it comes to force, what we are using? This is called as Newton. Sorry, this is not kilogram, this is gram. Gram. So these are the standard units. That means wherever in the world, for calculation purpose, we are using these things as standard unit. Mostly in this chapter we will go with length in meters and time in seconds. And there is an important thing. Okay, there is an important thing. Just inject this thing into your mind. Inject it. That means till your death you must not forget that. Understand? Length always comes in meter. Understood? Always comes in meter. And regarding physics, or not only in physics, in other chemistry also some problems are there, but numericals are not there. Numericals are not there. But if you are going for engineering field, you want to face a lots of numericals. Understand? Lots of numericals. At the same time, there's lots of derivations are there. Equations, derivations, numericals, problems and all. You must inject this thing into your mind. That is, whenever we are doing numericals, first of all, what we want to do? You must convert what all things given in the question into their standard unit. Understand? Into their international system, we must convert it. Otherwise, you won't get the correct answer. Okay? How much hard work you have done, how much knowledge you have, if you didn't convert it into standard unit, you won't get a mark. For example, the question is, Ramu travelled 1 kilometer in an hour. Mention these in standard units. 1 kilometer in an hour. How you will mention in standard unit? Distance travelled by Ramu, 1 kilometer. We want to convert it into meter. You will get 1000 meter, isn't it? That is the standard unit of 1 kilometer. time, 1 hour, how many seconds? 60 to 60, 3600 seconds. Understood? So never forget these things while doing your numerical problems. I think for 10th standard also I didn't told that. Anyway, 10th standard their physics class didn't start. I will go through that. In 10th standard also the same thing. It is useful. Understand? Not only 10. PUC first year, PUC second year. If you are going for graduation, if you are going for engineering, what all calculations we are doing. Even in medical also, medical field also there are some calculations are there, calculations. In calculations, you must convert that into what? Standard units. Otherwise, you will 100% you will get the wrong answers. Okay, so these are the basic standard units. I will download a chart and I will post in that WhatsApp group. What you want to do? You want to just copy it into your CW and keep it safe. And this conversion also we will discuss afterwards. Conversion actually it comes in mathematics. If you are having any confusion, you can post that in the WhatsApp group. We will take one class for conversion for 8th, 9th and 10th also. For example, how to convert grams into kilograms, how to convert meters into kilometers, centimeter into meters, centimeter into kilometers. Isn't it? So like that. These are the basic units. So whenever you are doing numericals, because in physics numericals will come. I know you are not interested in numericals. It will be difficult for you at the first time. Okay, this is the introduction time of this physics numerical in your life. That's why this will be a bit difficult for you. But these things you must keep in mind. Never forget that. So that's it. Next class, what we will do? We will go with displacement, distance. This is a 2-mark question. Displacement and distance. So for that, I hope you are interested in getting knowledge regarding physics. Okay. So next class we will start with the chapter. So till then, stay at home, stay safe, my dear kids. Okay. Till then, Within Raj signing off from this part of the world. Bye bye. Take care and Jai Hind.